Hello guys, so let's finish off this paper as our form of introduction to grade 12 mathematics paper 2 material. Now we're going to handle analytical geometry, a very simple and very easy usually section to navigate. And this is where most of students get marks. Okay, now I will highlight the strategies to approach each section on a paper on a separate video. For now, let's just build you up into the level that you need to reach. Now there are some instructions here that we need to use analytical methods in this section. So this means mostly we're going to have to perform calculations typical of analytical geometry, but somehow certain things do come together. Construction and measurement methods may not be used. Remember, may does not mean should not. It's very different. It means it may not, but where the need arises, that can come in. But you can't construct and then measure. That's the idea. We can construct and perform analytical means. That's good. All right. So that's the most important message being propagated in that statement. Let's look in question 1. What are we doing? In the diagram alongside point A, which is, with coordinates of -2 and 3, we can see it. With B, coordinates of 3 and 2, done. C with those coordinates of k and -5. So already, if it is given like that, it means that is a potential question. Okay, now at 3 points in a Cartesian plane, and we can see they form a triangle. M is the midpoint of AC. Can you see? Maybe let's leave it like this. So we can see that AM is effectively equal to MC, and this lies on the y-axis. What does that tell us about the coordinates of M? It tells us that the coordinates of M is some 0, it's some y value and 0. And of course the y value, we expect it to be negative if we ever find it. That's very important. And then we're told also that BE is perpendicular to AC with point E on AC, so that's fine. That already tells us if we are to look for the equation of this line, we can use the gradient of this line once we know our K. And then of course K is an X coordinate, so we expect a positive answer in there. All right. So that's what we can do, guys. So what can we do? This is what we are given. What can we do with it? Now we look and say, okay, we have coordinates of that line segment AB. We can actually find the gradient of that line. From the gradient, we can substitute this into some standard format of the equation and get the equation of this line. And from the equation, we can read off the y-intercept. That's about what we can do with that side. Secondly, knowing that this is the midpoint, so what we can do, we've got both the coordinates of, the y coordinates at A and C. So we can use the midpoint expression to find that y value. So we simply say y at C plus y at A, that would be -5 plus 3, which is -2. We divide that by 2, then we get -1. So we know that this is -1 right there. So this is good. So we know that y is -1. Now we've got 4 coordinates of M. That means we can find the gradient of this line AM, because these are collinear points. We find that gradient, we substitute a point, we get an equation of this line. From the equation of this line, we can substitute point C and solve for K. So we can actually find K that way. All right, okay, all right. So essentially we can even get the angle of inclination from the gradient. That's about what we can do. We can even work out the x-intercept if needs be. Truly, and then using the gradient of AM and the gradient of EB, since these are perpendicular, we can find the gradient of this line and its equation. From the equation we can work out its y-intercept, and that's about what we can do. So it looks like what we have been given, we can work with it. What about the coordinates of E? Well, this would be the point of intersections of the line AM or AC and that, so we can solve simultaneously. Then we will get the coordinates of E. So this is more typical of grade 11. So this is what we can do. Now guys, once we have understood our graph and we know what we can do, remember, part of what we imagined or thought about is most likely going to be one of the questions coming for us. And that already means we have a plan for those questions. But now the best way to approach analytical geometry, since it is easy to score some marks, is to skim and scan these questions before answering them. Unlike the issue of Euclidean geometry. With Euclidean geometry, you often don't know where you're going. You have to take it step by step. But analytical, you can check how many battles can you fight. And you pick those and you fight them quickly because it can bank you time to do that. Write down the value of k. Now, can you see? Write down, and it's for 1 mark. So this is already suggesting there's an easier way than finding the equation by finding the coordinates of M, get the equation, then substitute. But either way, if this is the only way you see it, you do it on the side on your rough work, then you come and plug the value of k, because nobody cares how you got it. But here's the easier way. Now we'll look at this and say, using symmetry, since this is the midpoint, right? So we can clearly see that from -2 we got to 0, because this 0 is very important. From -2 we got to 0 horizontally, because this is an x coordinate. So that means from here we transform this point by moving it 2 units to the right again. So this should be exactly +2. So we know that k should be 2. So can you see, using symmetry, easy. But you can go about it the long route. You will still get the value and just come and plug the answer. So we can see that, okay, we can sort this out as fast as it is dictated. Calculate the size of angle A, round it off to 1 decimal digit. Well, if we look at angle A, we will appreciate for sure that angle A is that angle here. So we've got this coordinate in 4, so we can use the cosine rule, because we can find the length of AC, find the length of AB, find the length of BC, and then use the cosine rule. We are sorted. Okay, always just check, okay, this is worth 7 marks, it's good. Determine the equation of the altitude BE. Can you see, we want the equation. Of course, knowing the coordinates of C, we can use the gradient of AC together with the gradient of EB to find the gradient of EB and substitute the point, and we get the equation. So we can get those 4 marks. Determine the coordinates of E. We know that once we have this equation, we just need the equation of this line, which we did not determine, but we would know the gradient already. So we just find the equation, we solve simultaneously. That's about 6 marks in paper 1 usually. We can take that one down. Calculate the area of triangle ABM. Triangle ABM. So we can see that this is the triangle. Obviously, we will have the coordinates of E. We can calculate the side EB. We can also calculate AM by finding the coordinate, the y coordinate at M. So if we can get that distance, we get this distance just using the area standard style. I mean, this is enough for 6 marks. But we can even use the area rule, because we've got that angle from above. We can calculate this side and that side. And if we used the cosine rule here already, so we just need 2 things, the side AM and the side EB. Then we plug them, we sorted. So can you see, guys, you know that here I'm not going to suffer. I'm taking all these marks. This is the question you want to answer. And you can do it quickly because you know most of the steps that you need to take in answering each question. So let's start. 1.1. We want the coordinate of k, so we're going to write k is equal to 2. Done. We saw that with symmetry, we just ask ourselves, if we moved point A to M, because symmetry says we moved point A to M. So this is 0 and some y value. Not interested because k is the x value. So we say from -2 to 0, we added 2. That means we can add 2 to 0 to get to C, and that would be 2. Symmetry, simple. But you can go about it using the midpoint expression, using the x side of things. That can also reveal that, Or we can go even the longest way. Find the y, get the equation, substitute this point. Not a problem. But you see, you want to bank time for other questions. Calculate the size of A rounded off to 1 decimal place. 7 marks. Obviously, this is suggesting that perhaps we need to go around doing that cosine rule, because this is the best thing we can do right now. Otherwise, I don't see why we should suffer other issues. So we can say, well, C is essentially, maybe let's start here and say in triangle ABC. Now, what are we going to say in that triangle? We know that the coordinates of C are now 2 and -5. We need to state that. So what are we going to say? We know that now we want AB. Okay, maybe let's start with AC. It's going to be the square root of the x coordinate at C minus the x coordinate at A, all squared, plus the y coordinate at C minus the y coordinate at A, all squared. So that is what we have. We substitute. X at C, it's 2, minus x at A, it's -2, so it's going to be +2, all squared, into y at C, it's -5, minus that one is 3, all squared. So we just sort it out. So we've got the square root of 2 plus 2 all squared plus -5 minus 3 all squared. So we get 4 root 5, okay? So this is 4 root 5 units, okay? That's what we want. Now we want AB is equal to the square root. This is going to be x at B minus x at A all squared, y at B minus y at A all squared. Some smart people often just jump in and substitute. But the danger is that if you don't have a structure, you are most likely going to make a mistake and not see it. And therefore you lose marks because of just carelessness. So don't be lazy. X at B is 3 minus x at A. It's going to be +2 all squared. Plus y at B, it's 2 minus 3 all squared. So be meticulous, guys, because these are easy questions, honestly speaking. Now from the above, we just change the values that we need to change. It's very easy. So we get square root 26. Okay, so that's it. And then we go and find BC. So again, guys, as I said, laziness is easy to entertain, but it hurts big time because it impacts on what you get and you don't want to regret not doing something meaningful with an opportunity that you were given. So x at c is it's 2 minus that at b. Y at c it's minus 5 minus 2. So let's get stuff going. Again, we just go on and change the structure, but be very careful of using the structure that you already have if you don't pay attention to how those things are. Rather write anew everything if it needs to be like that. But again, just double check your substitutions. If they are all good, then you press answer. And then we have 5 root 2. Something makes me wonder, is AB really root 26? This is 3 minus 2. That's 5. That's 25. Okay. This is 1. Sorry. Yeah, this is 1. So that's 26. Yeah. It looks okay. It looks okay. All right. So once this is done, we can say then we know that we are looking for this angle. And therefore the side opposite is what takes the square. We know that BC squared is going to be equal to AB squared plus AC squared minus 2 times AB times AC times the cos of angle A. This is the cosine rule of triangles. So that's something you need to be comfortable setting up. You've done this in grade 11, so it shouldn't be a problem. Then we substitute. We have 5 square root 2 all squared equals AB, this is square root 26 squared plus AC, this is 4 root 5 squared minus 2 into AB, this is square root 26 times AC, which is 4 root 5 times cos of angle A, which is what we want. So don't forget to write caps for angles. Now guys, we just isolate A. We don't want to waste time. So we know that the cos of angle A is going to be this square 5 root 2 squared minus you know what, it's easier to transpose this to that side and this to this side, because this is going to be the square root of 26 all squared plus 4 root 5 all squared divided by wait, we still have to subtract this one, which is 5 root 2. Now guys, if you don't know how to do this quick, then you're in trouble. Okay, just remember that you are in trouble. And then when we transposed it, it becomes positive. So this is going to be 2 into square root 26 into 4 square root 5. So if you don't already know how to do this, you are so dead. So dead. You are just a mere corpse. Yeah. This is the one. Shift course. We do all of this business right here. So this is going to be the square root of 26 squared plus 4 root 5. Why do I now have 4 root 5? Hey, okay, yeah. Is the 1 squared minus 5 root 2 squared divided by 2 into root 26 into 4 root 5. Okay. Therefore, our angle A. Alright, so let's calculate. We've got shift cos. We have our situation there. Square root 26 squared plus 4 root 5 squared minus 5 root 2 squared, okay, divided by 2 into square root 26 Hey, come on my throat, what are you doing? When I'm busy you act up, and when I'm not doing anything you are fine. Stop being such a sabotage, you bastard. Anyway, so we are getting, remember we're told to 1 decimal place, so this is 52,1 degrees. So we follow the instructions. So this is it, guys. Can you see? Not very complicated. Yes, a 7-mark question demands a bit of work for sure, but we have handled it nicely. So obviously, guys, what matters here is these marks, okay? Then substituting into the cosine rule, that's the 4th mark, and then getting the answer in the required format, 5th mark. The 6th mark is setting up the cosine rule in the specific triangle. Yeah, man. That is essentially the 6th mark. I don't really see where the other mark comes from. You know, maybe it's a bonus for your pains. But I guess the algebra is important, whether one wants to consider this step or this one. But if everything is on point, we have the marks in full. 1.2. I mean 1.3. So what do we have? We are to determine the equation of BE. Okay, not a problem. So we know here, first of all, that the gradient of BE multiplied by the gradient of AC should be equal to -1. Now, why is this? It's because we were given that essentially BE is perpendicular to AC. So when that is the case, that is the property we can apply. This implies the gradient of BE into, we're going to do this nicely. Sometimes it's easier to just substitute here now. So we can take y at C minus 5, we subtract y at A, then we take x at C, we subtract x at A. This is equal to -1. And then this implies that the gradient of BE into, because we will need this gradient maybe, we don't know, we want to show it. So this is -8 divided by 4. So this is -2 is equal to -1. Very interesting stuff. So therefore, the gradient of BE is going to be a half. Okay, we can see it's a less steep gradient. This is quite steep. Not a problem. So we can say then we know that BE, the line BE, will be such that y equals a half x plus c. Now through point B, which is 3 and 2, we will see that 2 is equal to a half of 3 plus c. Therefore, we know that our c will be, this is 3 over 2, it transposed to this side. 2 minus 3 over 2 is the same as 4 minus 3 over 2. So this is going to be 1 over 2. Yeah. Is it 1 over 2? Wait. We're taking 3 halves from 2. Yeah, we remain with just a half. Interesting. You know most these things. But hey guys, don't trust your mental thingies there. Just confirm on the calculator in case there is a mistake. So we know that y is going to be half x plus a half. So that's the equation. Very easy, not a complicated calculation otherwise. So obviously we are scoring 4 marks. First of all, this gradient is important and that gradient is important. Substituting that point, key, in the final answer. So this is how we score those 4 marks and we move on. 1.4. We need to determine the coordinates of E. So we know this is quite a hefty number of marks. So obviously it's a more of a higher grade question indeed in a higher grade paper because others have been fairly standard just to prevent a fail. Okay, now let's see what is going on here. We can do this by finding the equation of AC, so we don't really need to worry about M per se. So we can easily say, well, we know that essentially AC as a line is essentially y equals, we saw the gradient was minus 2 there, so it's going to be minus 2x plus c. Through point A, let's use the point that was given so that we run away from our own passions here in case they are misleading. Therefore, we can see that our c becomes, this is 4, we transpose, we get minus 1. And we saw that this was minus 1, so oops, it's good. It's really good. Therefore, y is equal to minus 2x minus 1. That equation is important because we need to solve simultaneously. So we can say at E, it is such that, well, the line AC, but maybe let's just say here at E, what are we going to say? This is the point of intersection. Okay, let's think. We don't even have to say a lot, guys. We just equate these two. So we know that minus 2x plus c is equal to that one of half of x plus a half. Easy. This is what we need to do. This is the point of intersection. We don't need to explain things. I don't know what I'm doing here. I really don't know what I'm trying to do. This is what I'm trying to do. Now we collect like terms. We bring the half in here. So 2 plus another half is going to be minus 2 and a half is basically 5 over 2 minus 5 over 2 x equals, we bring in 1, so 1 plus a half is 1.5, which is 3 over 2. Okay, therefore we solve for x by dividing by minus 5 over 2. So this is as good as cross multiplying that. It gives us 6, cross multiply that, it gives us 10. So the common factor there is 2. We still get 3 over 5. But now this is negative, okay? So let's see, is 3 over 5 before point A? Yes, it is. 3 divided by 5 is 0.6. But now the problem is, 0.6 is between M and A, minus 0.6. So we can accept this. We can say therefore y as well is going to be, we can take any one, it's going to be minus 2 into minus 3 over 5 minus 1. So this is basically 6 over 5 minus 1. So we multiply by 5, 6 minus 5 is 1 over 5. Okay. Well, that's convincing because again this is below 3, this is above 0. So we can say therefore the coordinates of E are minus 3 over 5 and 1 over 5. Well, the point itself is in the second quadrant and the coordinates are agreeable. Whether this is right or wrong based on what we calculated, of course this is stuff that needs to be verified on the calculator before disaster strikes, okay? But let's just assume all is well, because this equation we saw that it's good, and then equating the two is proper, finding the value of x is good, and finding the value of y is also good. So this is 1, 2, 3, 4. Now we can say, yeah, doch 6, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, 6. Where's the 6th mark, guys? I'm an anxious. But I think maybe writing in the ordered pair. I mean, guys, when you have full marks, it doesn't matter where the marks are. You will not be squashed marks if everything is good, logical, and it gets to the answer. Doesn't matter how the memo looks, okay? There will be a way of giving you full marks. Okay, let's do 1.5. So 1.5, we need to find the area of triangle ABM. So we know that in triangle ABM, what do we see? Well, we need to find this height and this, we just need to find that. We can just write the coordinates of M this time. This is 0 and minus 1. We got this minus 1 from the equation of AC. It's the y-intercept, so we don't need to explain it. And then, what are we going to say? Maybe we can even say this is the y-intercept of AC, just in case someone is nosy. What are we going to do next? Because, I mean, remember, for 6 marks, guys, we need to put a proper argument. We can't be careless. Now, we want to find AM. AM is going to be equal to, as we know, the x at M minus x at A, all squared into y at M minus y at A all squared. So we do it. So what do we have? Y at M is -1. Minus that at A is going to be minus. Oops. What am I doing? This is X, not Y. Okay, X at M is 0 plus 2 all squared plus this is -1 minus 3 all squared. Okay, easy stuff. So guys, when you have a plan, you just write, but remember to be careful. Mistakes love you when you are confident, because you will lose marks with confidence and you wonder how that calamity happened. It's because you were not careful. Okay, so this is good. So what else do we need? We need EB. Like I said, to write this over and over sounds and looks stupid, but once you have a structure, it's easier to substitute correctly without allowing mistakes to creep in. But of course, it depends on you. Do you like to be in trouble, or do you prefer to always be comfortable and safe? Safety first. Safety first, and other things later. Preferences later, guys. Okay, X at B is 3 minus X at E. This is minus. What did we find? Minus 3 over 5 all squared plus Y at B. This is 2 minus 1/5 all squared. Okay, let's get it done. Now that I have a structure, I just sort it out nicely. So you see, these calculators provide a lot of, ease with the terrible situation. You end up, cruising when you should be suffering. Wabon. Yeah, man, it's like sword items. Okay, guys, what am I getting? So this one is crazy. I'm going to write it as it looks. So this is 9 root 5 divided by 5 units. Okay, now what is next? I need to just simply answer the question. Then we know that area of triangle ABM is going to be half the base, which is going to be AM, times the perpendicular height, which is going to be EB. Okay, this is a half into 2 root 5 into 9 root 5 over 5. Okay, so let's see. Of course, 9 by 2, that's 18. Now that's going to be 18 times 5. Yo. 18 times 5, that is 90. 90 divided by 10 is going to be 9. Okay, that looks convincing. So this is 9 units squared. Whatever the units are there. Okay, so this is good. Let's try again, just in case we are not being serious. It's easy, guys, to lose the plot here, so you just want to be easy on yourself. When things are easy, you double check, you triple check, you quadruple check. Because these are not marks to just throw away, because there's a plan for each one of those marks. Anyway, We needed to see those coordinates. However, we decided they are there. We needed to find this. We needed to find that, 3 marks. We set up the area, we substitute, we get the answer. Nice. Easy 6 marks for a total of 24 marks. Now you can see, guys, sometimes analytical geometry questions are fairly easy. They are not really difficult at all. So you just take your marks and move on. So let's get to question 2. Now question 2 is the typical grade 12 question. Right, let's read the statement for 2.1. We are told in the diagram alongside BD is a tangent. Who is this? A tangent. So what do we know? Tangent is perpendicular to radius. So if we draw a line of the radius here. Remember, we were only told not to draw and measure, but we can draw and use analytical relationships. So all we know is that the radius is perpendicular to tangent. Okay. So we know the radius is perpendicular to tangent because that is the idea. And now we can clearly see that if this is 90 and that is 45, this one should also be 45 degrees. So if these are each 45 degrees, it already suggests that the tangent is equal to the radius. 6 seconds in bed. Now you can see that this is an isosceles right-angled triangle. Okay, and we're told that this is on the y-axis, and then of course this is suggesting the coordinates of B is some y value and 0. Easy. Now we are told that the center of the circle is C. Great. The equation of the tangent BD is given by this expression. And then of course the best way is to write it like so. We transpose these ones and then we divide, we transpose everything, we divide by 3, by -4. So this is going to be essentially y equals 3 over 4 x, and then 8 minus 8 divided by -4 is going to be +2. Now this uncovers our y as 2. So we are sorted. Can you see? Easy things, guys. Don't rush to answer questions. I know you are in a hurry. You're thinking, yeah. No, now, can you see everything is revealing itself? This angle BDC is 45 degrees. We saw it, and we already used it to deduce a whole lot of things. Now we are set. What can we do with this? Don't worry about the questions first. Now we can find the equation of the radius. Yeah, we can. And we can find the gradient of the radius. Yeah, we can. And this already tells us that let's see, we've got the equation of this tangent. We will have the equation of the radius. In fact, knowing a point on the circumference, we can find the equation of the circle. Now from the equation of the circle, we can find the y-intercepts. We can also find the x-intercepts. But what about point D? How do we find point D? Well, to find point D is going to be interesting. Yeah. certainly interesting. Now let's think about how will we find those coordinates. Remember, we know that the radius is equal to the tangent's length. So we can find the length here. We already have the length. So we can find the length of DC using Pythagoras in this triangle. Now from that length, remember we still don't know the coordinates of D. So this is X and Y. So we will find one equation for the length. Knowing the Pythagorean theorem is going to give us the answer of the length, but we'll still have variables for the equation. Then the other thing that we can do, finding the gradient of this radius. Remember, if we become smart and we construct a horizontal line like this, draw this radius so that it's parallel to the x-axis. So we know that we're going to strategically do this so that we can find the angle of inclination of this radius. Now we can clearly see that technically we can actually find the gradient of this line, therefore. No. This is something different. So the key is to find the gradient of this line. So there's a whole lot of things that are going on now. Knowing that this is 45, we can find this angle right here. This angle will give us the gradient, and we can derive the gradient formula. We have a second equation, and therefore we solve simultaneously. We have the coordinates of D. So it looks like a bit of work, but that's a plan. So this is what we can do with what we are given, and it looks like we can thrive with it. Now let's see how many questions can we answer. Determine the coordinates of B. We saw that it's easy. We just work out the equation. Show that the equation of the circle is like this. We can do that. Easy 4 marks. Determine the value or values of Q if X plus Q is equal to 0. Is the equation of a tangent to the circle. So we need to sort this out. So we can just see that, okay, if this is X plus Q, this is a vertical line because this is nothing but X is equal to minus Q. So for a vertical line to be a tangent, it means it's sitting over here and perhaps over there on the other side. Well, is it good? Yeah, it looks goodish. It looks goodish, not really good, but goodish. Okay, it looks 90 degrees. I don't know why. Maybe this is the one that's bad. Yeah, that was the one that was bad. Okay. So we can see that this is something like SWA because this is a vertical tangent. So this already says we need to think about the radius going in that side. I don't know why. Is it going to work? No? Yes? No? It's not working. It's too small. Okay, let's just try. Okay, that's better. Okay, so you see guys, you plan your stuff. And then we know that, okay, the tangent is perpendicular to radius. Tangent is perpendicular to radius. So, if these are to be tangents, so it means they should be exactly horizontal, like this. I mean, from X, it means the X coordinate here. I mean the Y coordinate, sorry. The Y coordinate here is essentially, let's say, what are these points? We've got D, B, C, So we can say perhaps E this is point E. We know that this is some x value and minus 2. Okay. Now, and then also here, we can call this point F. And then the coordinates here is going to be some x value and minus 2. Because we know that the relationship of the tangent, if this is a vertical line, this must be a horizontal line, the radii. Okay, so we've got a lot of planes. We can see that this is a typical higher grade question. Essentially, you need to understand what is given for you to know what to do about it. Okay, so now we can see that we all need to find those x values. This is all we need to find. And of course, this is a positive x value, this is a negative x value. But how will we find it? We just shift this x coordinate here, the radius units ahead and the radius units back. And we can use what we just said. We were going to use the length of the radius using that line segment. Then we just simply shift this. So we will have all our marks nicely. So these are battles we can fight. Now 2.1.4 says, the A version, write down the length of BD. So that means obviously from knowing the radius here, which is going to be revealed from the equation. Once we have the radius, we will know that it's exactly the length of the radius. Hence it's 1 mark. So it's easy to take that. Hence determine the coordinates of D. Now, we can easily see that this is what we were expecting. A bit of a heavy hitter. Again, a typical higher grade question, because here we need to derive some simultaneous equations. The reason is we need to use Pythagoras to find BD, number 1. Number 2, we already have the equation of BD. We don't even need to find the equation. So we can see that this equation will have x and y, but this x and y is still very much a part of BD. So we can use the equation of BD simultaneously with that of the line DC, essentially. Or even better, we don't even need to use DC for that matter. We just use that line because we have the equation of this line. This would be something from the gradient, and then we use the length of this line as we know what it would be using the distance formula. We solve simultaneously, we've got the equation, the coordinates of D. So this is not too bad. So all of this other planning was good to think about, but it's a long way around. So we've got a shorter way. So we know we're taking these marks. Now, determine whether points E, like this, C and D are collinear. Okay, so now this is a different point. Can you see our E is already not doing the right things? Let's convert that E to G. Let's say that is point G, because now we've got point E which is introduced. So this point E is a point in the 4th quadrant, and we can see this coordinate is 2. So this is a point perhaps somewhere here, because it's before this point, after that point. So this should be point E with 2 and minus 9. Okay, not a problem. So we need to prove now whether this point E, C, and D are collinear. Question is there a straight line that joins these two like so? Okay, is this a straight line or is it a lie? Okay, we will find out. Of course, we'll just prove now that the gradient between C and D is the same between C and E. If that's the case, then those points are collinear. Not a very difficult problem, so easy, 3 marks. Now the last question says, determine the equation of the locus of point P, x to y, if the distance from P to R with those coordinates is equal to 2 times the distance from P to T, which is that. Again, this is a typical higher grade question, so anyone who doesn't know what a locus is, good luck with that. Check in the channel, you might find something. So can you see, guys, you know that all these battles you can win. Remember what I'm doing, I'm just taking time to explain to you. The time I take to explain and solve, you can cut in half, because you don't need to explain to somebody else. You just write. All right, good. And then, of course, you will have learned to speed up once you have the knowledge, the confidence, no fear. Now we are done, guys. We know what we can solve all of this. See, when you annotate your diagram nicely, everything just gels. Okay, 2.1, we need to determine the coordinates of B. So we know that, okay, AB was given, not AB, but AD is such that Y, maybe let's just give it the way it was given. We know that 3x minus 4y plus 8 is equal to 0. You can say therefore y is equal to 3 over 4x plus 2. Right. We can say safely therefore B is going to be 0 and 2. This is the y-intercept. So we know that x must be 0. If you substitute 0 there, we are done. So sometimes you don't need to say too much. So this is good. So technically writing in standard form is good, and the answer with some justification if you don't want to show us the substitution of 0 and all of that. That is just, for babies in the subject. In grade 12, you need to show that you have been transformed. How? I'm seeing that this line is slanted, guys. That's why I'm trying to. It still looks slanted, but I am much. So writing in standard form answer is good. But remember, answer only for a 2-mark question is good, because you get those marks, right? But when the question says determine, it means you can do by inspection, you can do by calculation, you can do by any means necessary, as long as you take us through what you did. Okay, so this is 2.1.1. Okay, so we have 2.1.2. Now we need to show that the equation of the circle is as shown. Well, we know that circle center C is going to be the standard format. We say x minus the x coordinate at the center. This is minus 3, then we square that. Plus, we say y minus the y coordinate. So minus 2 is going to be plus 2. All squared is equal to r squared. Okay, great. So we substitute point B, which we just found. We substitute, so for 0 minus 3 all squared plus 2, which is all squared, equals r squared. So what do we say? We can say r squared is equal to, now this is 9 plus 16, that's 25. And that's what we need, right? Therefore, we know that our circle equation is going to be x minus 3 all squared plus y plus 2 all squared is equal to 25. Now we sort it out. Maybe let's say this implies, or we can even say then, that is the equation which implies, we FOIL this out, this is x squared minus 6x plus 9 plus y squared plus 4y plus 4 equals 25. Okay, so therefore we write it in the format given. We know that x squared minus 6x plus y squared plus 4y minus, we transpose this, but now this is a bit dangerous, or it's not. 9 plus 4 is essentially 13. So 13 minus 25 is minus 12, equal to 0. So this is what we were supposed to show. So it already proves that everything we have done is good. Everything we've done is good. So of course writing in standard format is key. Getting r squared is key. Then I'm trying to think now, FOILing this out, maybe not necessarily writing in standard format there, but perhaps here where we substitute. Okay guys, you know what, yeah, this thing is challenging now. I still believe this is good. This is substituting the point, getting r squared, and then expanding this thing and sorting it up. I think that's good. I mean, if everything is done correctly, you still score full marks. Sometimes I don't know where the marks are. Anyway, so we know that we are done here. So 2.1.3. We need to get the values of this situation, but can you see, we know that certainly r squared is equal to 25. Therefore r is basically 5 units. This is from above. So we can say therefore the equations here is going to be x is equal to, we take the x value here, it's going to be 3. Then we take 5 units back, so we subtract 5 here. Or x is going to be equal to, we take that 3, we just add 5. This means x is going to be minus 2, or x is going to be equal to 8. And those are the equations of the tangents. Maybe let's write it clearly. Let's say here then, okay, let me see, then we can say then the equation then the equation of tangents as such that asingaqhelani kakubi ke sana, so sinihlanise. 10 wasikhethe islanti sakho manje. Okay, kushuthi nibhale udoti now. Okay guys, this is the stories. This is the stories. So now we need to work everything back now. Okay, this one is not the one. These equations are such that we have this. Which implies that x is equal to minus 2, or x is equal to 8. But remember, this was written in that format, which also implies that x plus 2 is equal to 0, or x minus 8 is equal to 0. Now we need to answer the question. Therefore, q is going to be 2, or q is going to be minus 8. Easy stuff. Okay, so can you see, when we understand what we need and how to use it, we really go far. We really go very far. So again, these are higher grade questions, guys. You need to be careful, and usually they're not really that hectic. You just need to understand. So of course, getting this dude is good. You know. So these values are key. So perhaps this step is more important, or even better, these two equations are much better because they reveal the answer. I mean, it depends. I think the most critical step is that, right? Right. The rest just gives us what we want. All right, guys. So this is good. Now we are fine. We are fine. So that's what we need. That's what we need. It is what we need. All right. Okay. All right. So we have 4 marks. Nicely. All right, guys, let's finish up this question. Now that was 2.1.4. We need to write down the length of BD. We know that, okay, in triangle, of course, if we write down, we don't stress. We can just say BD is going to be equal to the radius, which is going to be 5 units. Okay, of course, this is just 1 mark, so 1 mark is good enough for the answer, even if we don't justify. I think this needs to be somewhere. So this is A. B, we need to find the coordinates of D now. So this is good. All right, so we know that, well, BD is equal to 5 units. Okay, maybe let's just write 5. Or maybe let's just use our thingies. So this is going to be x at D, which is x minus x at B, which is 0 all squared, plus y at D, which is y, minus y at B, which is 2. Okay, good, all squared. This implies that we have 5 is equal to, I don't even know why I didn't do this. Let's forget this business. Sometimes to go around the bush is a waste of time. We can just write BD squared. It's going to be like that. So this is 5 squared equals, this is just x squared, plus we FOIL this thing out. Do we need to? Not necessarily. So this is y minus 2 all squared. So we can put it nicely and say, therefore, we get that 25 is equal to x squared plus y minus 2 all squared. You can make that equation 1. The other equation, we know also that BD, the very same line, is given by y equals 3 over 4 x plus 2. But do you see this y is the same as that y, because this is all on BD. So we can substitute. can say then D is such that we have 25 equals x squared plus, instead of y, we write 3 over 4 x plus 2 minus 2 all squared, which implies that we have 25 equals x squared plus. Now these two do the magics, and what do we have? This squared, so this is going to be 9 over 16 x squared. This implies that 25 over 1 is equal to multiply by 16, so that is 16. 16 plus 9 is 25 over 16x squared. Nice and easy. So what are we going to do? What are we going to do? Well, we are going to do what we do best. So this implies also, remember, when we divide by this, we multiply by it flipped. So if we multiply by it flipped, it means x squared is going to be equal to 16. Then we take the square root. If we take the square root on one side, we must do it on the other. So we can say, therefore, our x is going to be 4. Y, maybe let's say x at D is 4. We're choosing this one because it's the point in the first quadrant. We can also say, therefore, y at D is going to be, we choose a simpler equation. We know that this is 3 over 4 into 4 plus 2, which is 3 plus 2, this is 5. We can say, therefore, D is the point 4 and 5. Was that difficult? Not too difficult. As long as you know what to do, you do it. If you don't know what to do, please die. Okay, don't die simply from joking. Does that point make sense? Yeah, it's not very far. I mean, it's between this point where this is 8. It makes sense for it to be 4. Because this is 3. It's just ahead of this one. And then it's above that point. So for it to be 5, I can accept it. So even if everything has gone wrong somewhere where we misplaced some numbers and what, it happens. But the approach is clear, guys. Here I'm only about teaching you the right approach to solutions rather than getting the exact correct solution. It's not about that. Of course, maybe this is me trying to, excuse myself for my mistakes or excuse myself for my incorrect calculations. But remember, I am not the one learning. You are the one who's supposed to learn. So here I'm just giving you approaches and how to see what you need to use to get to your answers. Then it's only your job, guys, to verify that everything is on point, because obviously I am distracted. There's no question about it. My mind is all over the show. Okay, so let's do this 2.1.5. Because I do believe there's enough space to prove collinear points is not a problem. So let's see the gradient of, let's say, CE is equal to, let's see, this is going to be y at C, which is minus 2 minus 9. That's plus 9. Now, guys, I'm in a hurry, but don't be in a hurry. Write the formula nicely and substitute so that you don't make mistakes. If you start jumping in, you will make mistakes, believe me. But now I'm doing it because I can, okay? So this is going to be 3 minus 2. Right. What is this equal to? This is 7 divided by 1. So this is just 7. Yeah, that's quite a steep gradient. I know. I'm going to try to write the next one here and say, what is the gradient of CD? So we found out that y is 5 at D minus that at C is going to be plus 2. That one was 4 minus 3. This is indeed 7. So we can say, therefore, the gradient of CE is equal to the gradient of CD, which is equal to 7. Therefore, points E, C, and D are collinear. Nice. So obviously, guys, what is important here for 3 marks is to prove that the gradients are equal, and of course the conclusion and any one of these calculations. Nice. Why am I giving 4 marks? Are you crazy? 3 markers. Alright, guys, so let's do the last one. Now this one is gonna be a bit, you see, this one used to be a problem, but yeah, it's not really a problem, but usually you need to construct here. I don't know why this question was taken away, because honestly that's the essence of analytical geometry. The rest is just baby stuff. Okay, alright, okay. So what are we going to do now? Let's quickly get to this. Determine the equation of the locus if the distance. Now we need the Cartesian plane. Let's draw it. So there is our Cartesian plane. Now we need to try and approximate that point. So R is a point in the 4th quadrant, right? So maybe we can say this is 1. And then we can say this is 1, 2, 3, 4. Maybe over here this is 4. That would be minus 4. So where these come together, okay, we can just drop a line. That must be parallel to the axis. And then we drop another one. I mean, we don't really need the other one. So it is here. So there's our point. So this is 1, this is minus 4. And then we go on and sort the other one. This is point T, which is a point in the 3rd quadrant. So if we said this is 1, maybe over here, looks a bit far. Is it? Yo, doch. No. I think that's 1. I think that would be 2. So this is minus 2. And then we're taking minus 1. So this is that, minus 1 probably there. Then of course we draw this thing going in there. And we just draw. Remember, it's not going to be exactly accurate, guys. The intention is just to get the point that we want. Everything else is not that important. Okay. Now we've got those 2 points. So we've got point R with these coordinates 1 and -4. And then we've got point T, with those coordinates -2 and -1. All right. Now, what are we saying? We are saying this point P, which is the locus point, it can be any point. We are saying this distance of this point. So this is probably a point here. We don't know where it is. Point P is any point on the Cartesian plane. Point P can be here, can be here, can be even collinear to this. It can even be, I mean. Can you see there's so many possibilities? So again, a strategy is important. Do we really want to do collinear points? Maybe, but no information was given. So this one is bad if we try it. So let's just leave that point P in the first quadrant. We are told here that the distance from P to R is equal to 2 times. So from P to R, we draw this one. Wherever P comes from, we just do it. That is the one. That is the one. Okay. We are told that this distance from P to R is equal to 2 times the distance from P to T. And you can easily see that if we tried to assume a bit of an accurate sketch, it almost looks like that indeed. Okay, not exactly like that. Okay, we don't know, but these ones look almost alike. But we are told something, that the distance from P to R is equal to 2 times, meaning this one is double that distance. 2 times the distance from P to T. So this is what we have. So obviously, guys, this is distance formula. We just solve simultaneously and get the equation. Not a big deal. We don't need to suffer. There's nothing to try here. Just use the distance formula. So we know that basically PT is equal to PR. 2 times PT, is going to be equal to PR. Right. Because we were told the distance from P to R is equal to 2 times the distance from P to T. Yes. So this means 2 times PT gives us PR, because this distance would be 2 times that distance. Nice. So be very careful. Now remember, we don't want stories here. We can square this thing, because if we start doing other things, we will suffer. So this implies we have 4 times. Now PT is essentially x at t, which is 1. Okay, maybe let's use p instead. So we can say this is x minus 2, so it's going to be plus 2 all squared, plus essentially y minus 1 is going to be plus 1 all squared. This is equal to PR squared is going to be x minus 1. Is it minus 1? Yeah. x minus 1 all squared plus y plus 4 all squared. Alright, so we just simply sort it out now. What do we have here? So we basically have 4 into x plus 2 all squared plus 4 into y plus 1 all squared equals x minus 1 all squared plus y plus 4 all squared. Okay, it looks like we're not really getting anywhere, are we? Yeah, we need to FOIL this thing out. We need to FOIL it out because nothing, there are no like terms here. There's nothing here. So we will have 4x squared plus, this is basically 2x, 2x is 4x times 4. That is going to be 16x. This is going to be 2x times 2, that's 4x. 4x times 4 is 16x. Okay, plus this is 4 times 4, that's going to be 16 again. Plus we have 4y squared. Plus this is y times 2, that's 2y times 4, that's 8y. So this is going to be plus 4 equals x squared minus 2x plus 1 plus y squared plus 8y plus 16. So there's a whole lot of magics that are going to take place. 16 and 16 will do us the honors and go because they're the same sign when we transpose things. And then we are going to handle 4x squared and x squared here. So 4x squared minus x squared is going to be 3x squared. Okay, then we've got 16x plus 2x. That gives us 18x. Not 8x, 18x. And then what do we have? Clag 1. Y squared, 4y squared minus y squared. It's going to be plus 3y squared. And then now we've got 8y and 8y, so they do us the honors, they go away, they take each other out. So we've got 4 and 1, so 4 minus 1 is 3 equal to 0. Alright, it's not bad. We can divide by 3 throughout. So we get x squared plus 6x plus y squared plus 1 is equal to 0. Wow. So guys, you can leave it here. I think so. This is an equation of a circle, but sorry, sometimes I think it's nicer to write it in standard form because it already tells us we will have a circle here. we will have a circle here. So this is indeed an equation of a circle that passes through some center. In fact, sometimes the question could easily say describe the equation of the locus. So we first work it out. But I mean, this is a proper expanded equation, but we can decide. I mean, for 7 marks, guys, I don't think we need to do a lot. I don't think we need to do a lot. I do believe this is safe to leave here. This is safe to, so we can say the equation of locus px is to y is such that this is the story, and then we go on to sort it out. If you like, you can complete a square. I don't know if it is necessary. So we take what is here, we take what is there, we follow the same sign, we have it, then we square it, okay? And then we say the same here, we take what is there, take the same sign, we have that, then we square it. Then we take this one across. We will take 1 to this other side, so it's -1. So we then say this squared is 9. 9 squared minus 1 is 8. 8 plus a quarter. 8 plus a quarter. This is 33 over 4, so we can leave it as 33 over 4. Okay, I don't know. One can think about this one as an option to complete the square, because it will depend on the mark allocation. But there was no mention of whether we need to complete the square, because an equation of a circle, we can give it expanded, we can give it in standard form. So unless the question would suggest that determine the equation of the locus P and write in standard form, whatever it is, then we would know what to do. So I think it's optional to get here. All right, guys, so this is it. How many marks are we going to score here? Of course, you know, for me, this is good. This is good. 2 marks. Yeah. Guys, this expansion, that's another 2 marks. So this is essentially, you know, guys, we're just doing algebra here. So this is 1, 2, 3, 4, 5, 6, you know. We can just easily say here is the general substitutions, the extra mark. So in the nutshell, we have 7 marks, and then, guys, we are taking some lousy 27 marks. So the equation of the locus is usually not easy, not difficult, because you just take what is given. Sometimes drawing a sketch can be considered, because it helps one to figure out what to do. So however one writes this, it will depend on the memo, but I do believe even if you leave it there, because that is still the same thing as this. Okay, that is expanded, this is factorized. This marks the end of our attempt, guys, to give you something. And obviously these kinds of questions can be asked indirectly. You wouldn't know. We used to name it and say this is the locus, but it may be brought to you in such a way that you don't see it is so. Okay, right. So that is the story, guys. That is the story. So I hope this is good. This is good, I hope. Now, folks, I am done. So sometimes in our exams, we would be asked to describe the equation of the locus P when this relationship is given. So obviously for us to describe, we would have to then, this would be a suggestion that we need to go into sorting it up so that we can understand. This is the equation of the circle with center -3 and -1/2. -3 is to -1/2, and a radius that is essentially the square root of 33/2 units. That would be a full description. Or someone may say write in standard form to suggest this is where we need to go. Okay, this is it, guys. I hope you enjoyed the video, and you're going to give it a thumbs up, and you're going to be saying to yourself, I am now ready for grade 12, because this is going to be work for term 2, essentially. Trigonometry and Euclidean geometry is term 1 work, so it's going to be part of your exam in term 1. So pay attention to some of the tricks and tools that I've shown you. And then we are going to now seal this session by giving you a video on tips on how to approach a paper 2 in grade 12 with regards to the sections that I have shown you. And then from there, we will do a video now taking you through term 1 past exam question paper. The most recent ones are the best. Maybe I can do 2 term 1 papers to try and give you what is coming so that you can get ready. As you start attending classes, you are ready. You are more than ready, because trust me, guys, if you practice these things, you don't just watch and wait for that day when you go to class. Most of this is going to be like a distant memory. So if you practice it regularly, some questions, yes, are going to be very difficult to figure out because your brain hasn't kicked into school as yet, but you're just trying to get your brain right in the zone. Now, when the classes start, you will be doing mostly revision for term 1. If you started with me now, like this, you need to re-practice these very same questions I have shown you. Even the ones that don't pertain to work of term 1, do them so that when you get to them in term 2, you are already fresh from that and there's something already in your bank. You just take it from there and move forward. So now this should make you guys be in a position to score that distinction straight up in term 1. And then of course I will try to then do a video for you taking you through term 2 work, that is June exams. Again, maybe 2 papers should be enough, because I mean there's plenty of papers in the channel. You can then play around any of the papers I have done, but do yourself one justifiable action. Re-practice these papers. Don't watch and it's over, you move on. Watch and re-practice to make sure you've gotten it right and you understand everything that you had to go through. You will get stuck, trust me, you will get stuck. You don't understand how things look so easy when someone is doing, and how challenging and daunting the whole thing is when you have to face it yourself. Do that, you will see. And then slowly move into other questions. When you see your confidence is ascertained by you being able to replicate what you've seen and what you've understood, then you can take a challenge now. Pick a question that you have not seen, play around it the same way. Don't rush, take your time, do it. Look for possibilities. Take your textbook, your study guide, put them down there. Look into those study guides and see if all the information that is now being summarized makes any sense when you are combining it with what you have. Then you take any textbook, you open that section that we did. If it is analytical geometry, you go to analytical geometry. Open now a section in your grade 12. Read through the sections and make sure you understand the examples. You redo those examples yourself after understanding, just to check in case You think you understood them and yet you don't. If you find yourself getting stuck, just know you had misunderstood something. But of course, take it easy. Don't rush to try and use memory at this stage. Just work through things nicely, methodically. Just know how to get things done when everything is readily available to you. Once that is over, do all the exercises. They are graded up until the very end of the section or the chapter. Now, at the very end of the chapter, you are ready. Then you can look in your study guide if you have. Try all of those. Don't rush for past exam question papers. We've already introduced you to them. So do all the groundwork. Now, trust me, when all of that is right, take some past exam question papers now on different levels of difficulty. Play around them. After that, you will know that your knowledge is settled. Then take your pen, be it any page, just take any page or any book. Take your pen and try to summarize that chapter without opening the books now. Summarize the chapter, get down the formulae, and see how many you will remember. Don't worry about trying to get them right. See how many you will remember. Just write down whatever you can remember. Wrong or right, perfect or not, just do it. Summarize the sections. Read the book again so that you can make corrections. You'll be surprised how so many little things you may have misplaced and misunderstood. But now when you read again, you start to understand better. You start to see better. Then, of course, you do more past exam question papers. You do your homeworks. You do your projects. Of course, guys, now you are ready to then time attack exam question papers now that you have not yet done. Now, check in the channel. If I've done some questions that you have not seen, you have not watched already, download those papers. Mostly STEM Physics has lots of those papers. Essay exam papers, get those papers from there. Usually those two sites are more than enough for a matriculant. Don't waste your time with many other sites where you have to pay for this. Download those papers. They have memorandums mostly also included. Download those memos as well. Then start time attacking those questions. Now remember, your knowledge is solid. You're just going to time attack now those sections, those chapters that you're dealing with. Time attack them first individually. Just be able to bank time on a particular question. Time attack. See how you got. See where you're getting stuck, you don't understand. You check the memo. If you still don't get it, you watch my video. If you still don't get it, well, it means you're not supposed to do maths. Anyway, guys, I'm joking. Goodbye. I'll see you some other time. So we will have a video where we talk about how to approach a paper 2 by using an example of a past exam question paper. We will not necessarily solve it, but I'll just try to show you how you plan your way around the question paper. And then let's see if this will help you to be more than mentally prepared. You should be hungry for that exam, meaning anxiety is no longer an issue. It's going to be more like the joy of dealing with the challenges. I'll see you next time. Goodbye.